Hello, this is your special education virtual content specialist with the 8th grade math lesson for May 28th. This lesson, like all lessons, can be found on TeachHub. For teachers, we provide the title, the focus question, and the learning objectives, including standards and objectives for each lesson. Additionally, we provide guidance for using the resource, including instructional and technology guidance, implementation guidance for the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging with students with disabilities and multilingual learners. 8th graders are going to continue working on Unit 8, the Pythagorean Theorem and Irrational Numbers. Day 23, edge lengths and volumes. What is the relationship between the volume and the side length of a cube? For the introduction, students are asked to let A, B, C, D, E, and F be positive numbers. Given the equations on the left-hand side, arrange A, B, C, D, E, and F from least to greatest, and explain your reasoning. To support students with disabilities, I provided 6 spaces so they can arrange the letters from least to greatest, and a place for them to explain their reasoning. The order that students should place their letters in are F, B, D, E, A, C. A sample response would be that we know that A is equal to the square root of 9, which is equal to 3. Since E is equal to the square root of 8, it is slightly less than 3. Since C is equal to the square root of 10, it is slightly greater than 3. We know that B is equal to the cube root of 8, which is equal to 2, because 2 cubed is 8. And since D is equal to the cube root of 9, it is slightly greater than 2. Since F is equal to the cube root of 7, it is slightly less than 2. Additionally, to synthesize the activity, you can ask a student to share their order of A, B, C, D, E, and F from least to greatest, record and display their responses for all to see. Ask the class if they agree or disagree. If the class agrees, select previously identified students to share their strategies for ordering the values. If the class is in disagreement, ask students to share their reasoning until an agreement is reached. You can also have students share and ask them which were the easiest to find and which were the hardest to find. Introduce students to cube root language and notation. Remind students that they previously learned the equation c squared equals 10 has the solution c equals square root of 10. So similarly, we can say that the equation d cubed equals 9 has a solution of d equals cube root of 9. Finally, tell students that while square roots are a way to write the exact value of the side length of a square with a known area, cube roots are a way to write the exact value of the edge length of a cube with a known volume, which students will do in the following activity. For the I do, it states if the volume of the cube is 125 centimeters cubed, then what is the length of each side? Explain your reasoning. In the synthesis, you introduce them to cube root, and you're going to model it explicitly for students now. If we say that one side of a cube is s, that means s times s times s is s cubed, and s cubed is 125 centimeters cubed. So to find one side, we have to do the cubed root. And so the cubed root of s cubed is s, and the cubed root of 125 is 5. So the length of each side is 5 centimeters. For the we do, students are going to think about between what two integers is the length of each side if the volume of the cube is 20 centimeters cubed, and to explain their reasoning. Thinking about their prior knowledge of estimating between which two integers square roots were, they're going to apply this knowledge now to cubed roots. So students would think that my perfect cubes are 2 times 2 times 2, which is equal to 8, and 3 times 3 times 3, which is equal to 27. 20 is in between these two values, so they would say that the length of each side is between 2 and 3. Now for the you do, students are going to find the exact value of the side. So students now have that support from the we do and know that the answer has to be somewhere between 2 and 3. And so if students are utilizing a calculator, they get that the cubed root of 20 gets you approximately 2.71 if you're rounding to the hundredths place, or 2.7 if you're rounding to the tenths place. But because they want an exact value, they can just keep it as the cubed root of 20. For this slide, you can now provide students with this reference, which you can put either physically in the classroom or in whichever learning platform you use. So cubes have volume, and the edge length of a cube is called the cube root of its volume. In this diagram, the cube has a volume of 64 units and an edge length of 4 units. Hence, both of these equations are true. 4 cubed is 64, and the cube root of 64 is 4. The cube root of 64 is pronounced the cube root of 64. Like square roots, some cube roots are rational numbers and some are irrational numbers. For this portion of the Explore, now students are going to add measurements for several cubes that are included in the table below, and to add in missing information. To support students with disabilities, I've added this square and this square. That way they can focus on less information that they have to supply. For the first row, each side is 3 inches. The volume is 27 inches cubed. So the volume is 3 cubed is equal to 27. For the second row, the sides are 4 inches. The volume is 64 inches cubed. So the volume equation is 4 cubed is equal to 64. For the third row, the cubed root of 5 is the length of each side. So the volume is 5 inches cubed. And the volume equation is the cubed root of 5 cubed is equal to 5. For the last row, each of the sides are the cubed root of 19 inches. So the volume is 19 inches cubed, and the volume equation is the cubed root of 19 cubed is equal to 19. For the activity synthesis, students had previously learned that knowing the area of a square is sufficient information for stating the exact length of the side of the square using square roots. So the purpose of this discussion is for students to make that same connection with the volume of cubes and cubed roots. The cube root of the volume of a cube represents the exact value of the edge length of a cube in ways that measuring or approximating by cubing values do not, except in special cases such as perfect cubes. So you want to discuss what integers would the cube root of 5 be between. And so it would be between 1 and 2, because 1 cubed is equal to 1 and 2 cubed is equal to 8. What integers is the cube root of 16 between? It's between 2 and 3, because you know that 2 cubed is equal to 8 and 3 cubed is 27. Another prompt you might want to give is name another volume for a cube with edge lengths between 2 and 3. A cube with a volume 26, for example, has edge lengths between 2 and 3, since 3 cubed is equal to 27. So that means the cube root of 26 has a value slightly less than 3. At this portion of the lesson, students can record their response to the focus question. What is the relationship between the volume and the side length of the cube? And to support students with disabilities, you can provide them with a sentence starter here as shown, to have students focus on the content of their answer rather than the structure, and then students can complete the cool down. This lesson was created utilizing illustrative mathematics and open up resources, so please feel free to use them to support digital learning. If you have any questions, feel free to reach out to your virtual content specialist. Thank you.